I thought I will say a few words about data import and export in Earth Engine. So the motivation is the following. As most of you probably have already discovered by now, the users of Earth Engine come from very diverse backgrounds. And they come from different programming language background, different kind of data they use. Sometimes the data can be proprietary, they could be public, and all of that. Earth Engine data catalog is really good in making available a whole lot of publicly available data sets, and importing them and so on are very easy to do. So the pointers that Ujjwal mentioned while giving an overview of the documentation, if you go back there, you will find plenty of pointers on how to search through those catalogs and import them into your script and work with them. But like I said, many of us are also sometimes interested in just using data that may not yet be there or may not be there at all. It's just proprietary. Maybe you even purchased it. It's not free at all, and so on. So the good thing about the way Earth Engine is structured is that you can bring all of that data into Earth Engine and use Earth Engine computation resources just fine, just like you would be using any of the data sets already on their catalog. So I thought this would also be something interesting and useful for beginners to know, namely the fact that if you go looking for your favorite data set in the catalog, and if you don't find it, that's not a showstopper. You should be able to, if you can get your hands on that data set yourself, you should be able to bring it into Earth Engine and use it just like any other data. All the computation resources and all the advantages apply just the same. So just to give a quick overview of what I'd like to cover, I'll go over quickly the concept of Earth Engine assets, because that's how the data are stored in Earth Engine under each user. The assets can be either raster or vectors. They can be input data that you bring in, like I just mentioned, but they could also be intermediate or final results coming out of your analysis. The advantage here is that the scripting and the API for Earth Engine allows for very easy read in and write out of data from within your own script, and they can go into assets and they can go to one or two other locations as well. We'll come to that in a minute. Also, I wanted to say a few words about the ownership of the data that you work with and bring in and all of that. Just a quick pointer that the Earth Engine developers resources that Ujjwal pointed to, that also has an entire section on data, bringing in your data and so on. It's under Earth asset management, and you can look through it at your leisure. So just an overview of the Earth Engine assets. Once you sign up for Earth Engine, by default, you get a free storage of about 250 gigabytes in your asset space. You can see that when you go to the assets tab on the left of your code editor window. You can make new assets, you can organize them into different folders, you can, and uploading of raster or vector data happens through this window. You'd go to the assets tab, click on new, and follow the instructions to upload. And if you're familiar with working with image collections in Earth Engine, it's encouraging to know that if you want to upload an entire set of images and work with them as an image collection, this interface in the Assets tab makes that very easy also. You can upload all images individually and drag and drop them into a new image collection you make, things like that. So the UI for this tab is built to be fairly useful and flexible with just clicks and drags and so on. Of course, for those of you who might want some more fine-grained control on these assets, that also is possible. but that will involve some installation on your local machine. You'll have to install a Python API, and you will then be able to do much more fine-grained control of your assets through what is called a command line tool. And like I said, all of this is mentioned in the developers' resources. I encourage you to check it out when you feel the need for it. Coming to the part of bringing your data in, so typically you would upload them from your local machine. If you're working with rasters, that would be geotiffs. The system puts a cap of 10 GB per image of upload. So if you have to upload larger files, try to break them up into smaller chunks. Rasters, so the raster assets can also be TensorFlow records. Just a shout out to TensorFlow. That's another Google Cloud Computing platform for machine learning. And only very recently, Earth Engine and TensorFlow got integrated for much more seamless and easy working together. And many people find it very useful when they're working on large geospatial data, like what the Earth Engine's strength is, and TensorFlow computations, which is basically very strong with machine learning. So one of the ways you seamlessly transfer data and talk to each other between Earth Engine and TensorFlow is by using raster assets in your Earth Engine account. So the other nice things to have also is in the same UI, there is facilities for editing and setting important properties you might have on your data sets. So for example, date for an image or any vector data can sometimes be very important. You can set it right there using the UI and go from there. Coming to the vector data sets, those are stored in Earth Engine as stable assets. That's what they're called. When you want to upload your vector data set into Earth Engine, you should make them into a shapefile and upload the entire shapefile. Just remember to include the accompanying files along with the SHP file, like for example, DBF and SHX and so on, while uploading your shapefile. Optionally, you're encouraged to include the .prj file as well, because that's what contains the projection of your data. And just know that if you forget to or choose not to include that in your upload, then Earth Engine will by default assume it to be a common coordinate system, which is lat-long WGS 84. Just the shapefile itself, there's another alternative you can use to upload, which is a zip archive of the entire shapefile and its accompanying files. Just be sure that a single zip archive that you upload will contain only one shapefile and that there are no duplicate file names. If these are not met, then it's possible to get Earth Engine confused and the upload might fail. You might be prompted to check for these mistakes and re-upload. There is an additional way of getting tabular data, vector data into your Earth Engine analysis, and that is via what are called Google Fusion tables. Some of you may already be familiar with it. This is very widely used in a lot of map making and data archiving and managing and visualization and so on. So if you're familiar with that, that's what this is. The good news is Fusion table can get read right into your Earth Engine script as a feature or feature collection. And the way you would make a new Fusion table is one of the ways is by uploading a KML file. So basically, if you have a vector data to upload, you would want to make them either into a shapefile or a KML and upload it and make sure you follow these functions, these conditions. You might sometimes want to also take your data out because maybe you're done analyzing, or maybe you just want to download some data that's already up there and so on. So the way to do that would be to export data. Images would get exported as GeoTIFFs or TensorFlow records. Vectors can get exported as any one of comma separated value file, shapefile, GeoJSON, KML, KMZ, or a TensorFlow record. There are multiple destinations you could export your data to. One is the asset, the Earth Engine asset, which I just talked about a moment ago. There's also the Google Cloud Storage, which is another option. Both of these are in the cloud. Of course, in the cloud also is your personal Google Drive space. So there are advantages and disadvantages to each of these options. For example, asset and cloud storage, they are very suitable for intermediate results because Earth Engine API allows for very seamless, quick reading in and writing out of data from assets or cloud storage. Typically, the assets also tend to have larger space availability, and cloud storage also is typically much more space that you can work with. On the other hand, Drive will have a few limitations, like the space, for example. By default, Drive has a much smaller space availability than either asset or even cloud storage. But when you want to bring data back into your local machine, for example, it is possible that Drive is your best option because that's right in your personal account. It's easy to point, click, and say download, and it comes right in. But the assets and data in the drive cannot be read into the script so easily as if they were in the asset or the cloud storage. So just ease of use and size of storage availability and so on, these are the trade-offs between these options. Depending on your needs, one or the other might work out best. While you're exporting data, just a few things to watch out for. Earth Engine API itself is built to be very flexible in how it handles data, how it handles data, computes on data, and transforms one from another, and so on. But when you are talking about bringing in your data or taking data out of there, you will be constrained by file formats of some of the popular file formats that are in use. So for example, if you have raster images to bring out of Earth Engine that come out of as GeoTIFFs, let's say, they have some GeoTIFF as a format has some constraints on what the band should be like and the data format in the bands and so on. So when you're exporting data out as a GeoTIFF, you might be limited by some of these constraints. Of course, these are quite generous, but the Earth Engine API itself handles more flexibility than some of these formats allow. So something to keep in mind while moving data in and out of Earth Engine. Similarly, shapefile, for example, has its own constraints as a file format. The geometry types, for example, have to be consistent and so on. So these are just some things to keep in mind while working with specific file formats. Also, Earth Engine, because it's a cloud computing platform and it's a shared resource, typically at any given point in time, there are multiple, I don't know, I'm not sure about the numbers, but surely hundreds or even more people parallelly working with the Earth Engine shared resource. So Earth Engine itself has a few guards against inadvertent large exports, for example, just so that some user just absent-mindedly doesn't end up initiating large exports and take up too much of the computational resources and time. So these guards are, again, like I said, very generous, and you typically don't bump into them while working, but sometimes you might, and in that case, the documentation is very clear on what to do to get around it, how to reduce file size, reduce export sizes, things like that. So all of this, of course, is easily available at the link at the bottom. It's a page in the developers resources. Other than just data exports, which everything I said so far holds for rigorous analysis, let's say scientific analysis, where you would have to bring in data, take it out, do more analysis, things like that. So that's one thing, but sometimes you might want to bring data out of Earth Engine just to visualize. And that is also very nicely laid out in Earth Engine. For example, if you can have an entire image collection of images, and you could export it into MP4 videos. It gives you flexibility to set frame rates, scales, dimensions, and so on. And the video can go into your drive, cloud storage. So depending on how large you expect the file to be, you could choose one or the option. The other visualization option might be to export an entire map. So maybe you did a bunch of data pulling and analysis and all of that and laid it all out on the map viewport in the code editor, and you're very satisfied with it and you want to bring it out just as a map. So it is more publicly accessible. Maybe you're building another website or something like that. So that kind of thing is also possible to do. So you can export an entire map, and that goes into cloud storage, and that works very seamlessly with the Maps API. That's also another Google service that you can make use of. And also these maps can be ported into Google Earth. And if you guys have had a chance to look up Google Earth on the web, it's a really nice visualization, and being allowed to bring your data into Google Earth and use the visualization in Google Earth can be very powerful for some applications. Of course, these exports also come with many tweaks and knobs that you can set to control parameters of your maps and exports. And lastly, a word about the data accessibility, sharing, ownership, and so on. Just want to take a few minutes and say, because I'm sure this is important for work that many people do and something that people might be curious to know. So all your data, like for example, whether it's in your asset or in your drive, it is private by default. And having said that, all of that data are also shareable to individuals, domains, or publicly to all, as you wish. Default asset and drive storage, of course, is free, but cloud storage and access may be charged. You can potentially get more data, more space for data, but potentially may be charged. But also something to keep in mind is there are free trial period offers and free cloud credits programs that you can apply for and take advantage of. And maybe all of those will come in very handy for your analysis and visualizations. So that's it from me. Like Ujjwal said, any questions you might have, feel free to ask them on the live chat, and we'll come back to them at the end.